Section 4.9 begins our journey into the world of going backwards from the derivative. We're going to call this the antiderivative for now. And it involves looking at functions. Let's go forward for just a minute. Let's say we have f of x equals x squared plus 5. And I go to take the derivative of this. That would give me 2x like that, and then, okay, so it would just be 2x. Okay, so there we have it. So if I want to go backwards, let's say all I was given was that the derivative equals 2x. And I say, well, what was that function before then? I can look at this and know that the x had to have been at the f of x had to have been at the squared level, because this power is a 1, and I see that that 2 dropped down. Now there's no way to get this 5 without any extra information, so for now I could just say x squared plus any constant would get me that derivative. So this would be called the antiderivative, as they're calling it here. So we're given some f of x, and we're supposed to give the antiderivative of this function. So let's see, I look at this x squared and know that it had to have been an x cubed, and I also see that when I took the derivative that 3 came down, so that 3 is good sitting there, plus c. So that would be what my antiderivative would be. So we're going to use the notation that they're using here with this capital F of x representing the derivative, or the antiderivative. Let's look at this guy right here. This one's going to take us just a little bit of work. Let's see. Oh, wait. Do you remember those inverse trig functions? Let me go get one of those. All right, here we have it. There he is. Look at that. Pretty as you please. If I take the derivative of the inverse tangent, I'll get that thing sitting right there. So f of x is inverse tangent x, and then I would get that thing sitting right there. But it could have also had plus some constant, even if that constant was 0. Could have been a plus 5 or plus 10 million for all I know. The next one, f of x equals the derivative of cosine, I know, is negative sign. So I got to kind of rig this a little bit. What if I put a negative out here? So the derivative of cosine is negative sine, and negative and negative. Oh, there she is. Alright, we have Theorem 4.17. This is a power rule for indefinite integrals, meaning that if I want to take the integral, and this is the notation we'll use from now on, it is the antiderivative. What it's saying to you is if you're taking the integral of just a plain old, let's say, x cubed dx, then when you went to, I know that this had to have been an x to the 4th. And when I went to take the derivative, that 4 should have come down, but there's not a 4 sitting out here. So if I plug a minus 1/4 in front of there, let's see, that 4 comes down, then there would be a 1 here. Then that's what this is about. It just tells you, be careful of your constant that's coming out front. This is just telling you that you can look at a polynomial as just a sum of functions, or not just a polynomial, but anything as a sum of functions, and take the separate integrals. Remember, we have to worry about things when it comes to division symbols and chain rules and product and quotient, so I have to be very careful here. So let's play this guy. This one says that I can take this independently and look at it as 3x to the 5th, and you do need to put this dx, means take it with respect to x. Remember your implicit differentiation, so I could take this integral with respect to y. So you need to specify, for the long while we're just going to be taking the integral with respect to x, so you'll kind of be a little confused as to why I'm putting it there, but eventually we'll get to putting a dy or a dz out here, and that'll make it even more exciting. So I'm going to take these separate integrals. This one, x to the 5th, had to have been x to the 6th, and when the 6 came down it made that a 3. So when the 6 came down it made that a 3. So if I had this guy over 2, 6 comes down, makes it a 3. There it is, or you could have just said 3 over 6. Plus just a plain old 2, that has to be a 2x, and then on this you can always double check yourself. Take the derivative of 2x, what do you get? 2. Should be sitting right there. This next guy, when I take the integral, it adds 1 instead of subtracts 1 because the derivative subtracts 1. So this, I'll add a plus 2 over 2. So let me write that in as a plus 2 over 2 so that I can kind of get my bearing as to what's going on with that. Okay, so it's going to be a minus, and fix my pen. Alright, so that would have had to have been, the 5 is hanging out there, that would have had to have been x to the minus 1/2, so that when it came down it subtracted 1 off of there and made it 3/2. And then underneath here I can go ahead and just put in that negative 1/2 because the negative 1/2 would have brought down, these two would have canceled. And I think that's probably about all for that. I'm going to say a plus c because it could have any constant there, and I'm going to simplify that nonsense there into 1/2 plus, x to the 6 plus 2x, and that'll just be a plus, let's see, 5, and then flip the 1/2, so that would be a 10, making that a 10, and then I would have the square root in the square root of x in that denominator plus c. Now if you want to leave it as x to the negative 1/2 you can. We don't usually like to leave things as negative exponents, and I know they gave it to you as a fractional exponent, so we could write it as 10x to the negative 1/2. Same thing. I'm going to go ahead and do my division here and get the integral of 4x to the 19th over x squared dx minus integral of 5x to the minus 8 over x to the 2nd dx. Alright, so simplifying that, I get integral of 4x to the 17 dx minus, let me do this number here, equals, and this I'm just going to go ahead and write as integral of 5x to the negative 10 dx. Now I'm going to take the integral. This would need to be 4x to the 18 over 18, and I'll simplify that in just a second, minus, and this would be 5, and this x would be, because I need to add 1 to the negative 9 over negative 9. Don't forget your plus c. I will count off if you forget that plus c, because that is a whole family of answers. And so this would be 2x 18 over 9 plus, and I'll just write this as 5 over 9x to the 9 plus c. Okay, I like that. Alright, next one. Now, I don't have any rules for the products yet, but I do have some sum rules, so I'll just have to multiply this silly thing out and then play. So let me do the algebra of that. Alright, now integrating the individual terms, this first one would be 2x to the 4th over 4 minus 5x to the 3rd over 3 plus 2x squared over 2 minus 5x plus c. Simplifying that crazy stuff, x to the 4th over 2 minus 5x cubed over 3 plus x squared minus 5x plus c. And we're moving right along, going backwards. Now this next theorem gives us some indefinite integrals for trig functions. Now notice that these are constants. A's are constants in this, not a function of x, just a plain constant. So I can work with these. Now I am looking at, for this A, I'm looking at this guy right here. And it says what you will do. My A in this case is 3. So this would give me 1 over 3 tangent of 3x plus c. Alright, in this case it's the same as looking at the cosine of 1/2 x dx, so my a is 1/2. So I go and find integral of cosine, there he is right there. This is going to give me, if my a is 1/2, 1 over 1/2 is a 2 sine of, and just the plain a, so it's just x over 2 plus c. Moving along. Here we're going to have a little more practice. This one looks a lot like this guy right here. So this integral of some a to the x, my a is a constant, so in this case my a would be equal to a -10, and you'll see that I would have this guy up here. So this will equal 1 over the -10 e to the -10 x plus c. And note, if I took the derivative of this guy, I would get what's sitting in there. I like to have my, I put my negative on top. I'll make it look a little prettier here. Over 10 plus c. That's cool. Alright, so we need to look and see in our table of integrals what it looks like this. It was some constant minus an x squared. I see him, he's right here. There's a constant minus an x squared. Now the a is squared, so my a in this case needs to be a 2. And this 4 is just a constant that's hanging out, and he will just hang out with the rest of the guy whenever I go to write down. My x is, so that would be a, I've got this one right here, so this would be a 4 inverse sine x over 2 and then plus c. If I were to take the derivative of this inverse sine, note that I would get what's sitting right here. Alright, moving on. This one is going to be, it needs to be a square root of a plus. So if I'm looking at this one, I'm like, not square root, I mean it's got to be some sort of squared and a squared. What if I were, I don't really see that because this is a constant times that x. Alright, wait. What if I did 4x squared plus 1 squared? Then it would look like this guy, where my a was 1, and in this case we'll call it my x is 4x. So I'm going to write this down, and wherever there's an a I'm going to put a 1, so it's 1 over 1 inverse tangent, and instead of an x I'm going to write a 4x over 1 plus c. Oh, I should have just written that as tangent minus 1 4x plus c. Take the derivative of this and you'll see that you will get what's sitting here. Alright, this is just kind of stepping you into it a little bit of differential equations. It's just a little bitty taste. So if this is my derivative, my f of x is going to be the integral of this, x dx. Alright, so let me get that. That would be x cubed over 3 minus 2x squared over 2 plus some constant. That's what my f of x would be. Let's clean it up just a hair, just to make it read x cubed over 3 minus x squared plus c. Now I know that f of 1 equals 1/3. That's going to give me my constant. So f of 1 is 1/3, and then the x's are all 1, so that's 1 cubed over 3 minus 1 squared plus c. I get 1/3 equals 1/3 minus 1 plus c. Looks to me like c equals 1. That means that my f of x is x cubed over 3 minus x squared plus 1. And that gives me my original without having to have that constant hanging out. Okay, for this next problem, we have a runner A, and runner A has a velocity of 2t. We're concerned about where he is, what his distance is, or what his position is. So what I really want is I want to know what s of t is. So s of t, so I'm going to take the integral of this v of t, which is 2t with respect to t, and I'll get that runner A has a position of 2t squared over 2 plus some constant. Well, I know that he has an initial position at 0, 0, so I can get what that value is. So when t is 0, s is 0, so 0 equals 0 squared plus c, so my constant is 0. That means that my s of t for runner A is just a plain old t squared. Runner B. Now runner B, his velocity equation is 2. That means I'm going to get his position equation by taking the integral of 2 with respect to t, and s of t in this case is just going to be 2t plus some constant. And my initial condition is when is s of 0 equals 8. So when t is 0, s is 8. So let me get that. 2 times 0 plus c. So that tells me that c is 8. So runner B has a position equation of 2t plus 8. So it looks like runner A is running on a squared, so I know he's going to move quicker at the end, but this guy looks like he has a head start of an 8. They want to know what time is 6, so s of 6 is 6 squared, which is 36, and s of 6 here is 2 times 6 plus 8, so 20. Who's ahead? Runner A. All you gotta do is give him a little time and he'll be ahead by a long shot. Alright, we're told that A of t is 9.8 meters per second squared, and it's in the downward direction, so we're going to go ahead and give him that sign. V of t would be the integral of this negative 9.8 with respect to t. So V of t is then negative 9.8 t plus c. I'm doing the a part here, and they give me an initial condition. They say it's thrown upward at a velocity. Okay. So that means v of 0 equals 40. So plugging that in, v is 40 minus 9.8 times 0 plus c. That lets me know that c equals 40 in this case. That's pretty nice. V of t is minus 9.8 t plus 40. That's my velocity equation. Let's do the position equation. I will take my velocity and take the integral of my velocity. So that is negative 9.8 t plus 40 dt. Alright, so I now have s of t is negative 9.8 t squared over 2 plus 40 t plus some constant. I bet you they give me a little bit of information there. At the very beginning, it's 100 meters above the water. That's what his position is. So S of 0 equals 100, which I'm going to plug in a 0 to all those, which it would then end up being the C. So S of t is then negative 9.8 over 2 is negative 4.9. Is that right? T squared plus 40t plus 100. Okay. For the C part, they ask me to find the maximum height. I know that mins and maxes occur at my critical points. So for C, well, V of t is actually the derivative of S of t, so I'll just say that 0 equals negative 9.8t plus 40, and move that over, then t would then be whatever 40 divided by 9.8 is, and I think that is somewhere in the neighborhood of about 4.1 seconds. So what's the maximum height? It occurs here, so I'll just do S of this 4.1 and crunch those numbers after I plug that all in. Alright, plugging all that in, I get about 182 meters. And the next thing what they want to know is, hold on, they want to know how fast it strikes the river. So I want to know if this is my height at all time, and my height that starts off, you know, I've got this cliff and it goes like this and then hits the river. I need to know, you know, really what time it hits the river, so that then I can plug that into my velocity. This means that I need for this height to be 0, meaning that I need to find the roots of S of t. I can do this a number of different ways. I could use Newton's method that we learned earlier. I could use the quadratic formula, because this is just a quadratic. I could use, they don't specify, so I could use my calculator's numerical capabilities, which is what I'm going to do. And I'm going to get that the root of S of t happens, it happens in two places, of course, because this is a quadratic, so I get it at t equal to 10.2 or t equal to negative 2.0. I'm going to choose this one because it's the only one that's reasonable, and that's the time that it hits the water. So the speed is the velocity at 10.2, equals negative 9.8 times 10.2 plus 40. And this would be at about 60, and I think we were in meters per second. And that concludes 4.9. Now if you have any questions with any of this, you know to see me in the Collaborate or email me. Thank you very much.